This meeting is being recorded.
Good afternoon, everyone, and welcome to Heat Pumps Explained. This is a session that we're putting on here at Hammersmith and Fulham Council to help you understand what heat pumps are, why they're so good as an alternative to gas boilers, and how this is part of our work to tackle the climate and ecological emergency locally. We've also got colleagues on the call from planning, so we can start to have a discussion about what this means in terms of navigating planning permission as well. So in general, pretty standard, but please be polite and respectful. We would love you to use the chat and ask questions throughout, and we will do our best to get to those in the Q&A afterwards. I think everyone should be on mute, so hopefully we don't have any background noise, and we will use the chat for question and answer rather than coming off mute or hands up. So please do use that throughout, and we will go through all of those at the end. If there's anything that we can't answer right now, we'll follow up afterwards. And just to say, you will get the recording and the slides afterwards as well. We hope that it's absolutely packed full of useful links and information that you can have afterwards as well. So don't worry about kind of scrabbling down all of the links that we share here as well. And so today's session is about heat pumps, and heat pumps are a form of low carbon heating technology and an alternative to gas boilers in how you can heat your home. And installing heat pumps and moving away from the burning of fossil fuels is all part of our climate and ecology strategy, which we were very proud that came out the top climate strategy in London from councils as named by Climate Emergency UK. But tackling the carbon emissions that come from our buildings is one of the biggest challenges that we have in decarbonising the borough and moving towards a kind of fairer and safer future and climate. 75% of the carbon emissions locally come from our buildings. So really moving towards low carbon heating technologies is a really important part of our work in tackling the climate emergency and implementing our climate and ecology strategy. So my name's Emily, I'm engagement lead for Climate Emergency, but today's session is mostly going to be run by Tim, my colleague who's the energy lead, and Roy, our colleague in planning and economic development. So we will cover what are heat pumps, are heat pumps right for you and some of the considerations there. And then we will talk about the boiler upgrade scheme, which is a new scheme from government that can give you money off installing a heat pump. And then finally, we will cover some considerations in terms of planning. So that's all from me. So I'm now going to hand over to Tim.
Thank you, Emily. Can you hear me all right? Give me a thumbs up. Great. Thank you. Hi. It's great to see so many people here, making me slightly nervous with so many participants on the webinar. I'm just going to talk through quickly what heat pumps are and why they're kind of, there's a lot of conversation, a lot of chat about them at the moment. I won't be able to answer all the questions around what heat pump will be right for you. The only way you're going to get a definitive answer to that is to have a qualified installer, and Roy and I will both talk a bit about that. Come to your flat or your house and do an appraisal to work out whether they will work well in your house. But I can give some pointers and hopefully kind of demystify things a little bit. So next slide, please, Emily. What is a heat pump? Fundamentally, it's a way of heating your home using electricity, not gas, which is a fossil fuel. Obviously, we've had electric heating in the past. I mean, a fan heater is an electric heater, for instance. So why are heat pumps better? Basically, a heat pump uses a compressor evaporator cycle, just like your fridge does or an air conditioning system does, to extract free renewable heat from the outside air or from the ground and then pumps that into your home. So for every unit, every kind of kilowatt hour of electricity you use to run that compressor, to run your heat pump, you should get several free kilowatt hours worth of heat pumped in from the outside air or if it's a ground source heat pump, which is less common from the ground. So that's why heat pumps kind of seen as a good thing at the moment. You will need, and kind of probably one of the key things here, and Emily had a picture of this on the first slide. If you want to flick back up and down again, Emily, feel free. You'll need an outdoor fan unit if it's an air source heat pump, and most heat pumps are air source heat pumps. So that's kind of probably the main kind of consideration. I'll talk a bit more about that in a moment, alongside the cost. And I've got a really wide range of costs there, simply because it depends on lots of factors. It depends on the size of your home. It depends on whether the heat pump is ground source or air source, and air source heat pumps are generally significantly cheaper. So that kind of £40,000 top range, then that's unusual. Most people are not going to be paying that. That's if you're installing a ground source heat pump, which is probably only going to be the case, for instance, in a really big house. Next, please, Emily. So why all the hype at the moment around heat pumps? Why are we hearing quite a lot about them? If you're kind of if you're listening into the chatter around decarbonising heating and decarbonising heat, well, most experts think that heat pumps are the best way to decarbonise our home heating systems, and that applies throughout the UK, and it also applies in London. I've just put a couple of reports there, which you can easily Google if you're geekily interested in this kind of thing. There's one that Element Energy, who's a consultancy, produced for the Committee on Climate Change, which looks at decarbonisation trajectories for the UK as a whole. And then on the right, heat pump retrofit in London, that was produced by the Carbon Trust specifically for the GLA and looking at the situation in London. But they both come to the same conclusion, which is that for most of us, heat pumps are likely to be the future of our heating systems. So not hydrogen. You might have heard about hydrogen. Certainly hydrogen has a role. And there may well be some of us that end up heating our homes on hydrogen, but it's not going to be, I think, most of us. And the reason for that is hydrogen is quite expensive to produce and needs quite a lot of energy to produce. And the hydrogen that is available is likely to be needed by hard to decarbonize sectors like aviation and industry. So there's probably not going to be that much of it left over to go into our homes. And probably not gas boilers either, like we all have at the moment. And the simple reason for that is gas boilers run on fossil fuels. Natural gas is a fossil fuel in the same way that oil is, the petrol you put in your car is, and it will therefore never be zero carbon. And in fact, also gas boilers are a really significant source of air pollution as well. And this has been in the news a little bit over the weekend, the high levels of air pollution a lot of us have in the UK. And the gas boilers we use to heat our homes are one of the main sources of air pollution that we confront, probably behind only cars and traffic. So that's another important reason for us to get rid of heat pumps. And I'll just put the final couple of points there. The kind of, we'll be running another session on the kind of really drastic increase in energy prices that we're all suffering from at the moment. But that increase in energy prices is being driven almost entirely by the cost of natural gas. And therefore, gas is getting more expensive more quickly than electricity is. Electricity is getting more expensive at the moment as well, because we produce quite a lot of our electricity in the UK from natural gas. But the bit of our electricity that we get from solar and from wind and from renewables, and that's going up all the time, that's not affected in the same way. And hopefully in the future that has been getting cheaper, and that will continue to get cheaper. Next slide, please, Emily. So just kind of a few pointers on whether heat pumps are a good idea for you, because they won't be right for everybody. Heat pumps are going to work for most of us. They'll work for most homes in London and in the UK, but they won't work for all. So it does depend a little bit. Next slide, please. And I think the main three things to bear in mind are these three things here. These are kind of the main 3 points I would be looking at and am looking at and thinking of whether I would install a heat pump in my flat or in my home. So the first thing there is how much heat does your home lose at the moment? How well, and that's kind of come down to two things. What's its form factor, by which I mean, what's the proportion of external walls to internal walls that border other flats or other houses, and how well insulated is it? heat pumps will work really well and will probably cost you less to run in a flat or a house that's well insulated, or that perhaps is mid-terrace and has lots of internal walls, or a flat that is not on the top or the bottom floor and has, again, lots of borders with other flats, because you don't have too much heat loss. And then the heat pump can produce quite low temperature heat, which it's really happy doing, and that makes it really efficient. So that's kind of the first factor there. If you've kind of got a solid wall house without cavity walls, with very little insulation, and your end of terrace, say, that's a situation when, certainly without doing some work on your house first, a heat pump is likely to work a bit less well for you. The second point there is how is the heat distributed around your home? So for most of us, that's via a wet heating system via radiators. Heat pumps like nice, big, efficient radiators. So they like convector radiators, they like double skin radiators. They don't like so much, say, the kind of old 1930s style radiators that don't give out quite so much heat per radiator. And again, the reason for that is that the heat pump can produce heat at a slightly lower temperature if the radiators are bigger. And they also like underfloor heating. So if you've got water-based underfloor heating, that's something that is likely to work really well with a heat pump. So if you've already got quite big radiators, you've already got underfloor heating, that would probably be a tick in the heat pump box. If not, it's again something you might, and that kind of goes back to the cost range I put up in the first place. If you need to replace your radiators as well as install a heat pump, it becomes more expensive. And then the third kind of key question, and I think the answer to this for most of us is going to be air, but the third key question is what's the heat source for the pump? So where is it taking that free renewable heat from before it uses a compressor to pump that into your home? For most properties, I think in London, certainly most houses, you're likely to be looking at air source heat pumps. For blocks of flats, it's a little bit more nuanced, and there are some good solutions available now for blocks of flats where you have a shared ground source loop, and a ground source loop is generally a bit more efficient than the air, that takes heat from the ground, and then the ground remains warmer in the winter than the air does, and then has a very small heat pump, probably about the size of a shoebox, not much bigger than a shoebox, within each flat, that then takes the heat from that ground source loop and amplifies it and makes it useful for heating your flat. So that's certainly a solution that I like and looks good for me for blocks of flats. But for houses, you're likely to be looking at an air source heat pump, and then you've got to think about where you put that outdoor fan unit that you've seen pictures of on a couple of slides before. You get something called monoblock air source heat pumps, which don't have an outdoor unit. They're really unusual though, and you probably don't want one of those, because then you've got the fan unit inside your house, and they're not really noisy, but they do make some noise, the fan units, and unless you've got kind of somewhere really good to put it that's well away from where you sleep and where you work, you probably don't want that fan unit inside your house. Next slide, please, Emily. A few other kind of lesser considerations around whether they're likely to be right for you. There are kind of, as well as air and ground source heat pumps, there are also different types of heat pumps. This gets a really complicated subject in whether they're high or low temperatures. How hot do they make basically your radiators? And then a high temperature heat pump will make your radiators basically as hot as your gas boiler does at the moment. So it will work with your existing radiators if they're not that big. But a high temperature heat pump is not as efficient. It doesn't get as much free heat from the outside air as a low temperature heat pump does. But both types are available. You can get grants for both types. So it's kind of just worth bearing in mind the high temperature option, if it might be really difficult to put in bigger radiators in your house or underfloor heating in your house. There are hybrid heat pump systems as well. And that simply means that as well as using the heat pump as a heat source, you're also using something else to help that heat pump along. Most commonly at the moment, that's probably a gas boiler. But you can also use standard electric resistive heating as a backup, like a fan heater, or you can use solar thermal as a backup as well. I will say this again later on, but just bear in mind the government grant scheme that's just been launched, the boiler upgrade scheme, will not give you a grant if you've got a gas boiler as backup, because the idea behind that grant really is to decarbonize our homes as much as possible, and that means not having a gas boiler. And then think about, of course, where your hot water is going to come from as well. So most of us who have gas boilers at the moment, that gas boiler makes your hot water as well, either through a combi boiler that produces the hot water on demand, or through a storage tank where the boiler heats the water and stores it for later use. Heat pumps can absolutely heat your hot water as well. And to get a grant, to get the government grant, you have to have the heat pump producing your hot water, because you can't have a gas boiler. But to use your heat pump to make your hot water, you need to have a water tank. So if you haven't already got a water tank that will store that hot water, you will need to install one, because you can't use a heat pump like you do a combi boiler. It won't produce your hot water on demand as you need it. Certainly a question I think is worth asking yourself as well is what your current boiler is like. So if it's quite inefficient, if it's not a condensing boiler, if it's likely to need replacing soon anyway, that makes the case for a heat pump stronger, because your heat pump is more likely to be more efficient than your old boiler, and you're going to need to replace it anyway. And what this kind of all really boils down to, what I'm kind of driving at really here, is that a heat pump is quite likely to save you money. It will save a lot of people money, but it won't save everybody money. So if you've kind of got some of the things, the bad things I've been talking about, like your house is not very well insulated, you've got solid walls, you're a detached house, say, or maybe a top floor flat without very much insulation, and you've got small radiators, and your boiler, your current boiler is quite good and quite efficient, then it's less likely, possibly unlikely, a heat pump would save you money. And this is where a good installer will be able to give you much better advice on this than I'm able to. And any installer that you're looking at to install a heat pump should be certified under something called the Microgeneration Certification Scheme, or MCS. And I've got a link to that on a later slide. But yeah, I wouldn't have anyone who wasn't MCS accredited installing a heat pump or advising me on a heat pump in my house. And they have to be MCS accredited for you to get the government grants as well. So that's another reason to use one. But any good installer should be able to give you something called the seasonal coefficient of performance. And that basically is a kind of fancy term for the amount of free heat your heat pump gives you from the outside air or from the ground versus the amount of electricity you put into it. And it's just expressed as a factor of 1 or 2 or 3. So if you've got a seasonal coefficient performance of 3, your heat pump is giving you 3 times as much heat from the outside air as it costs to run, for instance. And 3 or above is generally probably a pretty good number, but that will vary depending upon your flat or your house and the heat pump. And that's something, again, you would need an installer to give you advice on. Planning permission is generally okay. You don't need planning permission, but Roy will talk a bit more about that in a moment. And I've just put on that last point as well, just worth bearing in mind that the government at the moment has cut VAT on some energy efficient, energy saving equipment. So not all, you can't, VAT is still there on double glazing and LED lighting, and of course on boilers, but heat pumps are one of the pieces of kit they have cut VAT on. So at the moment, if you go out and you buy a heat pump right now, you don't have to pay any VAT. So that's a small cost saving, because it was 5% before that. Next slide, please, Emily. I'm nearly there. And I can't cover all of this because it's just too big a subject to kind of cover all in one go. But this is kind of true of if you're looking at any individual measure to try and cut your energy bills and cut your carbon emissions, you should always be thinking of energy efficiency first, or sometimes people term that fabric first. So if you haven't already insulated your house as well as you can, particularly the loft, because that's a really easy thing to do if you've got a loft, but also the walls, if you've got cavity walls and you're able to do that, and you find a good installer that can do that without, that understands cavity wall insulation and can do it without causing damp, then you should always be doing insulation and draft proofing first. And that's going to give you the biggest bang for your buck. You're going to get the biggest energy cost saving per pound you spend. And at the moment, insulating your loft, if it's not properly insulated, is going to pay back in a few years. It's going to pay back really, really quickly. Good heating controls, so not having heating on when it doesn't need to be on. A lot of us haven't kind of quite got that worked out. Looking at smart meters to work out, you say if there's stuff that's being left on overnight that doesn't need to be left on, you can turn off. Lighting, so LED lighting is almost always the best kind of answer now. Again, really quick paybacks over any other type of lighting. So I would, urge anyone to look at that. Plug load, I think I've said this before. So that means televisions and fridges and washing machines and computers. When you add all that up, they use quite a lot of electricity, and they take quite a bit of money to run. So every time you buy a new piece of energy using equipment, there will be a label with it that will tell you how much it will cost to run in a year and how much electricity it will use in a year. So if you're umming and ahhing between two different fridges, it's well worth looking at and then choosing the one that uses less energy, because it will cost you less to run. Make space for biodiversity and plants if you can, if you do have outside space. And then we covered this on a different session as well. For some homes, solar energy, solar PV can be a good option as well. Next slide, please, Emily. So kind of the final thing I just wanted to highlight is that there is a new government grant scheme out that covers heat pumps at the moment, called the Boiler Upgrade Scheme, or BUS for short. As you see, they thought about the acronyms there, and that will give you up to £5,000 to install an air source heat pump in your home, and up to £6,000 for a ground source heat pump. As I said at the beginning, ground source heat pumps cost a lot more than air source heat pumps, so proportionally, the grant is less generous for ground source heat pumps than it is for air source heat pumps. But for many people, that 5K towards an air source heat pump will be a significant portion of the total cost and will make the grant really worthwhile. And even for a ground source heat pump, it's clearly helpful. It's open to homeowners, so anyone who owns their home, or has permission from the freeholder to do work on their home. It's also open to small businesses as well, so it's just worth bearing that in mind. The third point there, you must already have loft and cavity wall insulation to get the grant. And this goes back to the fabric first point I was making earlier. It's a no-brainer to do that stuff first if you haven't already done it, and your heat pump will work much better if you've already installed loft and if you've got them cavity wall insulation. So that's a requirement before you can claim the grant. You have to have that. You can check that on your energy performance certificates, generally for the most part, your EPC. You must use a qualified installer. So you must use an installer that is qualified for the microgeneration certification scheme, but you will want to do that anyway. You would not want to use an installer that was not MCS qualified. So that's kind of not a problem. And it must provide, the heat pump must provide all of your heating and all of your hot water, other than you're allowed backup solar thermal. So you're allowed kind of solar thermal panels on your roof to get a bit of extra heat energy that you would normally use to help heat your hot water. But other than that, the heat pump must produce all your heating and hot water. That last point about shared ground loop arrays, I've really just put in for the benefit of people that live in flats. It doesn't look to me, this is a really new scheme. It's only just come out in April, and you can't actually apply for it quite yet. But I put this in just simply to try and kind of help people who live in a flat. It doesn't look like the boiler upgrade scheme is really aimed at people that live in large blocks of flats to me, because of this total system capacity limit of 45 kilowatts. And 45 kilowatts is not a huge amount. That would probably heat at the most, if they're really well insulated, 10 flats. So it might be, you might be able to get a shared ground loop array of the type I was talking about earlier to heat a block of flats, but only a very small block of flats under the scheme, from what I can make out. And then in the box on the right, it's just worth bearing in mind, there is another grant scheme called the Green Homes Grant that also covers air source heat pumps. And this has eligibility checks. So you've got to be on certain types of benefits to be eligible for the Green Homes Grant, whereas a boiler upgrade scheme applies to everybody. If you are eligible for the Green Homes Grant, it might be a better option for you than the boiler upgrade scheme. But other than that, the boiler upgrade scheme, everyone who's a homeowner is eligible for that. Next slide, please, Emily. I haven't been able to cover by any means everything in heat pumps. There's loads of stuff I've not been able to cover because it is quite a techie and complicated subject. And there are lots of different types of heat pumps as well. There are things, for instance, I've not talked about air-to-air heat pumps, which take heat from the outside air, but then pump that into the air in your house rather than using radiators, for instance. It's less common, it's usually less efficient. there are heat pumps that you can combine with mechanical ventilation heat recovery systems. So there are lots of different types of heat pumps, and a really good site for more information on heat pumps is that Energy Savings Trust link at the top left there. They've got lots of information that goes into significantly more detail than I've been able to here, and that will give you a really good idea about different types of heat pumps and how they work and what might be right for you. They've also got a page on the government grant scheme, on the boiler upgrade scheme. And then I put some links to UK government pages as well. So there's the kind of horse's mouth, if you will. Check your eligibility for the boiler upgrade scheme. It's worth bearing in mind, I didn't mention this earlier, but your installer applies for the grant. So if you're using the boiler upgrade scheme, you can't apply for the grant yourself. Your installer, your microgeneration certification scheme accredited installer, applies for the grant on your behalf. So your first step, if you're interested in looking at the boiler upgrade scheme and looking at these grants, is to find and contact a microgeneration certification scheme installer and get them to come and do an appraisal on your home. And then if you are happy and the installer's happy, then the installer will then apply for the grant on your behalf. That's the way it works. And then finally, I've just put a link to our climate change and planning pages, which has more information about heat pumps there. But rather than talk through that myself, I'll now hand over to Roy, who can do a much better job on that than I can.
Thank you, Tim. Thank you, Emily. I'm specifically going to talk about the implications of what Tim has been talking about in terms of the physicality of that on buildings. So what that means essentially is if you're going to put one of these schemes in, you may or may not need planning permission. Thank you very much, Emily. Next slide. So the question that everybody always asks is, do I need planning permission for heat pumps? That's pretty bog standard, and the answer to that is on the next slide. Most domestic properties do not require planning permission, and that is the case generally across the board. However, it's not a black and white answer. There are some grey areas, and there's a shopping list of things that need to be considered when making that assessment. Next slide, please. So what I've done is I've broken down to three parts. This is the first little section, which is on size and location. So when you're looking at an air source heat pump, which is probably for most people, the size of it is quite important. So it shouldn't be more than 0.6 cubic meters, generally speaking. Also, if there's already an air source heat pump on the property, an old one that's maybe out of date, that needs to be removed before you can install another one. So you can't have more than one system in operation. Also, if you have an air source heat pump that's close to a shared boundary with a neighbour, you can't really have that in that location. It needs to be situated 1 metre away from the boundary. And I can talk about that a little bit later on. Also, you're not allowed to put air source heat pumps on pitched roofs. You can have them on a flat roof, but not on a pitched roof. And if you do have them on a flat roof, it needs to be set 1 metre away from the edge of that flat roof to reduce the visibility of it. Emily, if you can just go up to the first slide, the slide that starts the presentation. There's a image on there. Yeah, so this, I think it's the one before that actually. If you go to the very first slide of the whole presentation, including Tim's, sorry, at the very beginning, sorry, my mistake. Yeah, so you can see there's an air source heat pump in the background there. And I was looking at that earlier thinking, okay, how tall is that and how wide is that, etc., and cubic content. And that's probably, if you can see in the background, there's a fence in the background, that's probably about 2 meters high. And that air source heat pump is probably about 1.7 meters, 7.5 meters high. And then it's probably about ½ meter deep, half a meter wide. So that image you see in the picture is probably about 0.8, 0.9 cubic meters. And that's the sort of thing that would need planning permission because of its size. But then also, if you look at that boundary fence, it's right on the boundary. So because it's close to the boundary, it's quite important consideration as well for us in planning terms, because then potentially, I think Tim mentioned this earlier about noise potentially to adjoining neighbours. So if it's within a metre of the boundary, that's a concern for us. And so in this case, it looks like this particular one would need planning permission, partly because of its closeness to the boundary and also because of its size. Okay, so thank you, Emily. So we go back to the second part. So that was just talking simply about the, if you like, the size and siting. And then this part, often again, we get asked, I've got a property in a conservation area, what happens, or I've got a listed building, or what are the constraints? So just taking you through those, and I call them heritage considerations. So in a conservation area, if you're on a wall which fronts a highway, then you would not have permitted development rights to be able to put one of these on the front wall in a conservation area. You would need to get planning permission. Also, if it's nearer to a highway that adjoins a property, then it means it would again need to get planning permission. So it's not to say that you wouldn't get planning permission, but the point here is that it doesn't have permitted development rights. And then outside of conservation areas, on a wall which fronts a highway, but at the same time it's above the ground floor, you would definitely need to get planning permission for an air source heat pump. So for example, in the image on the right hand side, you can see the yellow line, which leads to a box, which is at ground floor. And although that's the side of the property, if this was the front of the property and it was at first floor, that would need planning permission. But if it's at the side and away from a highway, then it wouldn't necessarily need consent. But that takes me to the next point, which is if it's a listed building, then there are restrictions on listed buildings, which mean that any sort of air source heat pump on a listed building would need to get planning consent. Now we have 500 odd listed buildings in the borough, so we have a list of those. And if you wanted to find out if your property was on that list, you could contact us. Similarly, half of the borough is in a conservation area. And if you wanted to find out if your property was in a conservation area, again, you could contact us. We can clarify that for you and explain the limitations. And then if you like, the main next consideration is in relation to an Article 4, because some properties, as I've sort of highlighted earlier, don't require planning permission. But if the Article 4 has been attached to a property, that essentially means that they have had their permitted development rights removed. And that means that property's been cited maybe because it's got particular detailing in terms of its design on the front elevation, the roof level or something, which means that we are concerned in terms of sensitivity. And if the heritage of that property was harmed in any way, it could harm the character and appearance of that building. So permitted development rights have been removed. So we have a list of 46 Article 4s in the borough. And again, you can contact us and find out if your property is affected by any of these. All of this information is on the website, but it's probably best to speak to us directly, and we'll come to that later. Thank you very much. Next slide, please, Emily. So this is the one that Tim has referred to about the quality of the installations, and I sort of alluded to it earlier. Essentially, if the installation doesn't comply with the microgeneration certification scheme, then it would need a planning permission. And the reason for that is this certification scheme is a national system, accreditation system, to ensure the quality and reliability of air source heat pumps. And essentially, just to give an example, sometimes we are in a situation in planning where somebody's installed something and we found out about it retrospectively, and then they say, what can we do? Does it need consent? And now if it complies with this certification, that's helpful because it's likely to be acceptable. If it's on a property that doesn't need consent in relation to size and all those other considerations I mentioned before. However, if it doesn't comply with the certification, then it doesn't benefit from permitted development. And the reason for that is that I think the best way to just sort of compare it with, if you think of a refrigerator in your own home and it's, gets to a certain point with age, is such that it's making a lot more noise and it's not as efficient. That noise and efficiency then means it might be a bit more clunky. Now, if that air source heat pump is situated within a metre of boundary adjacent to somebody's bedroom window or lounge window, or in some cases we've had scenarios where a neighbour has refurbished their home and got a nursery next door where their little one sleeps, and if you have an air source heat pump next to that, it can create noise and disturbance, which is obviously unneighbourly. So our responsibility is to try and mitigate that, and that might mean removal in some cases. So bearing in mind the cost of removing one of these and the cost of installing them, that's abortive work, and so we would strongly recommend that you find out first before you install this whether it actually meets that standard, and that's the responsibility of the applicant to ensure that standard is being met. However, as again Tim alluded to, there are professionals out there, consultants who install the equipment, and they are certified. and they should be able to identify those products which are suitable for accreditation in order to avoid that scenario of retrospective removal. Next slide, please. So overall, from our purposes, an air source heat pump, if you can try and site it away from neighbouring properties, as far as practical, that's probably the best thing, as long as it meets all the other requirements. And then Tim mentioned in the presentation ground source heat pumps. Generally speaking, these relate best to large properties. They don't normally relate to sort of small residential properties, terrace houses, detached housing to some extent. And they normally work best on large properties. So that being the case, the criteria is slightly different to air source heat pumps. So you need, so if you're going to do any excavation for a ground source heat pump because it's extracting heat from the soil, then that excavation shouldn't be more than 0.5 hectare, which is obviously quite a large amount. And again, you shouldn't have more than one of these on the property. So if you have more than one, then it would require planning permission. Again, just to make sure that if the system is no longer in use and not needed, then as far as practical, that should be removed and then the ground restored to how it was before the installation took place. And that's next slide, please. So try to simplify what sometimes can be a complicated area, but in short, we are available to answer questions in planning. We provide free advice to residents, and we can be contacted on the number below or preferably by the email address because that comes directly through to us. And also there are details on our website about Article 4 directions, conservation areas, etc. Again, we can advise you of those if you contact us. And we do actually have a climate change webpage which talks about retrofitting your property. And again, lots of the frequently asked questions that we get are on there. But again, if it's more helpful, it's probably helpful to contact us to sort of explain some of that to you, because some of it can be technical. That's it. Thank you very much, Emily.
Fantastic. Thank you, Roy, and thank you, Tim, for that really in-depth introduction. We have tons of questions, which is fantastic. So I will probably ask you both to be brief in your responses so we can get through as many as possible. And just to recap, that we will share this recording and the slides and all of the links afterwards, because I know there's lots of really useful content in there as well. So Tim, I might start with you, if that's all right, on some questions. Are heat pumps, if you live in a flat with storage heaters, are heat pumps a no?
I don't think, you won't be able to use, as far as I'm aware, I've never seen a heat pump that will work with your storage heaters. That's a good question, actually. So I think to get a heat pump, you would need to remove the storage heaters and replace them with underfloor heating or radiators.
Thanks, Tim. And then there's a question about water heating. So are there retrofit options for people to heat water only?
With a heat pump?
I think it's just in general. I'm guessing that could be solar thermal.
Yeah, I mean, I don't think I would use a heat pump just to heat my water, because they're really good at space heating. So I think if I had a heat pump, I'd want it to kind of be prioritizing heating my home, heating the air inside my home. You could definitely have backup solar thermal to help with your water heating if the heat pump, to take some of the load off the heat pump, say, to save some electricity, or if the heat pump's not quite enough on its own.
Thanks,
if
Tim.
I've understood the question correctly.
Yeah, I think it was just asking, rather than space heating, just about water heating.
But no, I don't think I would use a heat pump just for water. No, I think I would use it for space heating as well.
Thanks. There's a question here about what size block of flats, which I'm assuming relates to when you talked about ground source heat pumps. So do you know what size of a block of flats a ground source heat pump could service? So the example is there's over 200 flats in this person's complex.
And you could absolutely use a ground source heat pump. So you couldn't use an air source heat pump for that, but you could absolutely use a ground source heat pump for a really, for 200-300 blocks of flats. Indeed, you could use them for district heating schemes that run off, that would heat multiple blocks of flats as well. There is a government scheme that covers these really big heat pump led schemes called the Green Heat Network Fund. and that is designed to help. And it's not generally occupiers that would apply for that. It's generally developers or social landlords, for instance. So we're looking at it in our role as a social landlord, but a grant scheme that will help you install really big ground source heat pump schemes to big blocks of flats or to entire estates. And that's probably the best way to heat a big block of flats or an entire estate, is using a ground source heat pump or a water source heat pump, because you need a much bigger heat source than the air can provide for a building of that size.
Thanks, Tim.
Could I just preemptively, just in case you don't pick it, because there was one really good question I saw from Antonia, and I don't think I was completely clear in what I said. So she asked whether solid wall properties are actually eligible for these grants, given you've got to insulate your cavity wall. So I should have probably been a bit clearer on this. If you've got a cavity wall, you have to insulate it to be eligible for the boiler upgrade scheme. If you've got a solid wall, you don't have to insulate it. That's kind of seen as a harder thing to do. So if you've got a solid wall property, you are eligible for boiler upgrade scheme, but you would just want to bear in mind, if you're end of terrace, if you've got a lot of external walls, it might make it a bit harder for the heat pump to adequately heat your house. But if you're a mid-terrace solid wall property and you've got a well-insulated loft, then I would think that it would be worth looking into a heat pump. But either way, you're eligible for the grant.
Yeah, thanks for clarifying that, Tim. So Tim, another one for you, which is a technical question about how heat pumps work. Do heat pumps still heat water to then run through the radiators?
Yes, they do. Yes. So, well, most heat pumps do. So if it's an air to water heat pump or ground to water heat pump, and most of them are, they will use a compressor, evaporator circuit, or refrigerant to heat water, which then runs through your radiators or through your underfloor heating. So that kind of last bit of it is similar to your gas boiler, which will also probably heat water that will then heat your radiators, if that makes sense.
Yes. Yep. Fab. Thank you. Tim, another one for you. How can we measure levels of insulation and where heat is lost in a house?
So there are kind of two approaches really to that. There's kind of the theoretical approach, where if you've got a building element and you know what the wall is made of, and you know what the insulation, how the thickness of the insulation, the type of insulation in the wall or in the roof or whatever, then there should be a theoretical kind of heat transfer rate, or U value they're called. And that should give you a pretty good idea of what the heat loss is. The other thing you can do is use thermal imaging. So you can actually kind of aim a thermal imaging camera, and you might, if you Google kind of thermal imaging buildings or something like that, there you can kind of see these images on the web, and they'll kind of be lots of different colors. And the brighter redder colors will generally be used to indicate where a house or a flat is losing most of its energy from. So it's kind of, you can either measure it, or you kind of use the theory from knowing what it's built of and knowing what the insulation is.
Thanks, Tim. And I might just ask my colleague Jess to share a link as well to a scheme that we're going to be launching soon, which is offering free whole house retrofit plans to 100 households. And the idea of this is taking a whole house approach to this, rather than just looking at solar panels or just looking at heating technologies, looking at the individual solution for your home. So those, when we launch that scheme, please, you can sign up to this to be the first to know when it launches, with more details of eligibility and criteria and things. So I'll ask Jess to share the link for that, which is probably a fantastic place to start as well. There is a kind of another technical question, Tim. You kind of use the analogy of the similar to concept to an air conditioning unit at the beginning. Could heat pumps function as air conditioning during the summer months?
Yeah, no, that's a really good question. And yes, they can. They don't all. So you need a heat pump that's reversible, and they're not all reversible, but they're basically, they're using exactly the same kind of concept of pumping heat out of a colder area into a warmer area using a compressor. So there are some heat pumps that are reversible, quite a few in fact I think on the market, and you can use as air conditioning as well in the summer. I mean, I guess air conditioning is a bit like heating though, in that ideally we'd try and minimize our need for air conditioning and our need for heating as much as we can, by making homes as efficient as we can, as well insulated as we can, but also thinking about overheating and things like thermal mass and good ventilation, so that the need for air conditioning is minimized. But then, yes, if air conditioning is still then needed, a heat pump can be used to provide that.
Thanks, Tim. The next question here I'm happy to take, which is a question about estates and the kind of longer term plan in terms of retrofitting estates and moving towards low carbon heating, but then also a question about that intersection between sustainable drainage and making space for biodiversity, and then also space for heat pumps. So in response to that, we now have an officer working in our economy department who's developing the strategy to retrofit all of our council homes between now and 2030. So that retrofit strategy will kind of set out the plan over the next 8 years of how we will retrofit, upgrade, insulate, and move towards low carbon heating in our estates. And then the question about biodiversity there, absolutely, that's so important, and is sustainable drainage and preparing for flooding, as you've noted. And that's, I guess, the great thing about having a climate and ecology strategy all together, that we're looking at these things hand in hand, you know, as well as Tim, who's leading on energy. We have Seb, who's leading on ecology. And so making sure that all of those things we're looking at and balancing. So yeah, not kind of siloing and focusing on one issue or one part of the strategy at a time, that we'll be looking across all of those 5 themes, including ecology and adapting to climate change together. So there's a question here. I'm not sure if, I feel like you might have answered this, Tim, but can the council apply on behalf of tenants or tenants and residents association who are interested in applying for the grant? Can residents in social housing apply for this grant if they're living on estates, or does that fall under our retrofit plan?
I think that would fall under our retrofit plan. So I think it would be the council's responsibility to assess and apply for any grants and do the work, as far as I understand it.
Yeah, I think that's my understanding as well. I think so we've already answered how to understand your current insulation status. I'm just reading some of the questions here. So I think you've already answered this question. If you have solid wall insulation and can't install cavity wall insulation, Tim, you've already answered that. Thank you. Tim, I don't know if you know the answer to this one. Can you get cavity wall insulation in Victorian homes?
Depends. So most Victorian homes will be solid wall, not all, but most. And I think in our borough, probably pretty much all of them will. It tends to be in kind of wetter and windier parts of the country that the Victorians sometimes use cavity walls, because the original kind of aim of cavity walls was to keep the rain out, to keep the rain from coming through the wall. If you do have an older cavity wall home, the cavities are often a bit narrower than they are in more modern houses or flats. So you just need to be quite careful about how you insulate them and make sure you don't bridge the cavity, which can then let rainwater come in and might cause issues with damp. That's perfectly possible to do, but you just need a good installer who actually really knows what they're doing and is kind of qualified to retrofit insulation into older houses. But now most Victorian homes, I think, in our borough will be solid wall.
Thanks, Tim. And Roy, I know you talked about flat versus pitched roofs before. Can you just recap that? Can you put an air source heat pump on a flat roof?
Yes, you can, obviously subject to the other criteria about the size and siting, but yes, you can put them on a flat roof as long as they are set away from the boundary by 1 metre.
Thanks, Roy. Tim, a few more questions here about solid wall insulation. Do you have any advice or guidance to help insulate walls in order to comply?
So you don't have to insulate. If you've got a solid wall, you don't have to insulate it in order to comply. It's not a requirement of the grant. It's only a cavity wall you have to insulate in order to apply. So if you've got a solid wall, you can not insulate it and you can still apply for the grant. Whether that's a good idea or not is kind of a separate question, because, as I say, heat pumps don't work as well in houses that lose a lot of heat, like say a detached solid wall house. Insulating solid walls is it's a difficult subject. There's actually a bit of information about it on our climate and planning pages that I put a link to kind of in one of the slides further up that we will share after this call. But you basically got choice of insulating it on the outside solid wall, which is quite a significant piece of work and quite expensive, but does have the advantage that the thermal mass of your house is inside the insulation, which keeps it at a more constant temperature. Or you can insulate inside the solid wall, which is easier and generally cheaper, but also takes up some room space, reduces the size of your rooms a little bit, and means your solid walls are outside the insulation and are therefore a bit more likely to be cold and damp. So it's kind of, I would probably favor doing it on the outside of the solid wall, but it's a whole subject really, solid wall insulation in itself. And again, it needs kind of careful assessment, careful appraisal, and a good installer.
Thanks,
but you
Tim.
don't, just to emphasize, you can apply for these grants if you've got a solid wall and the solid wall is not insulated. It doesn't rule you out.
Thanks, Tim. Roy, a question here for you, please, about noise. So someone's experience in a different borough had been that they had to carry out a noise survey when applying for permission for an air source heat pump. Do we require this at H&F?
Yeah, when you're looking at permitted development rights, is what we've been talking about, essentially it's a path of least resistance. So if you tick all these boxes in this checklist that was sort of presented earlier, you don't need planning permission, then you can go ahead and do the work, as it were. But if you fail to meet some of these criteria, you will need to get planning permission. And when you're looking at something that requires planning permission, the considerations are slightly different, because we have to look at the local plan policies and think of all those policies. So we have to take those into account. And that means taking into account, for example, design and appearance, we've talked about that, but also noise impact. And I sort of touched on that before. If you've got something that's sited next door to somebody's bedroom and it doesn't comply with the certification system, then we need to make an assessment as to whether or not that would be acceptable. And what we would do is we would consult our noise colleagues in the environmental protection team, and their normal route of carrying out assessment would be to ask for a noise survey as part of the planning application. And that's pretty standard practice, because you or I or anybody that lives in a property, if somebody's got one of these situated next to a bedroom, we want to be sure that it's not going to cause us a nuisance or be harmful when you're sleeping in your bed at night. So the reason for asking for that is simply to make sure that it's acceptable. And the cost does vary, so I can't comment on that, but it does vary depending on who you get to do the work. But certainly you would be expected to submit a noise survey as part of the submission. Yeah.
Thanks, Rory. Just a question on noise. Do you know what the recommended decibel level is for these units?
Well, if it complies with the micro-regeneration scheme, then it's probably going to be okay. But I don't know off the top of my head, no. Yeah, but that's why we would ask our colleagues in the environmental protection team to look at it, because they are in-house experts and they would look at noise impacts. Yeah, so yeah.
That's great, thank you. Tim, again, on a bit of a technical level, is there a limit between the distance of the heat pump itself and the flat that it's heating? So for example, for a block of flats, could the pump be on the roof further away from the flat that it's actually heating?
Yes, so I think this is probably a question talking about the outdoor heat exchanger, so what we're looking at in the image there. And yes, I think provided that the kind of pipes going to and from that are properly insulated, which shouldn't be hard to do, I think you would be able to have that unit a reasonable distance away from your flat or your house. And then there'll also be a heat exchanger inside your kind of like their lit system. There's a heat exchanger inside your house or flat as well, but those are really quite small. I think they're generally smaller and quieter than gas boilers are, to give you an idea. The kind of main bulk of the unit is on the outside, if that makes sense.
Yes, yeah. I know we are running super short on time, and I know we have a ton of questions. So anything that we don't get to in the next minute or two, we will follow up afterwards. But thank you so much, everyone, for all of your questions today. Tim, just a couple more questions. Does orientation have any effect on efficiency? So if it's north or south facing?
That's a good question. So yes, for solar, solar PV, solar thermal, orientation super important. It's kind of everything. For a heat pump, it doesn't really matter. It might make a tiny difference if it's got a bit of sun on it and it can get a bit more heat from the outside air on a sunny day. But really, it's minimal. It's not something you need to worry about.
Thank you. And final question, let's go with for today. Tim, what's the average period of time an air pump should last for if it's serviced and maintained as regularly as it should be? Is there anything owners can do in terms of ongoing maintenance or reducing damage to the device?
So I think my understanding is that heat pumps should last at least as long as a gas boiler should do. And in some ways, they're kind of actually a slightly more simple bit of kit in some ways than a gas boiler, because it's just there's fewer moving parts and there's just a kind of single compressor and a fan in there. So yes, there's no reason why it wouldn't last at least as long as your gas boiler would. But again, I think most of them will need some kind of annual maintenance service. But again, that's certainly no more expensive and no more difficult than it is for a gas boiler.
Thank you, Tim. Thank you, everyone. And apologies to those questions that I didn't get to during the time. As I said, we'll take them away. We'll follow up the questions afterwards and share all of the links that we've shared today. Just before we finish, I might ask one of my colleagues to please put a link to our monthly newsletter, which is called Climate Connects. We are planning a whole program of events over the summertime, both in person and online. So if you want to be the first to know about other webinars like this, other events, please do sign up for that. That's definitely the best place to find out. And then also a link to signing up for those whole house retrofit plans to be the first to see when those launch. That would be fantastic as well. But yeah, thank you everyone so much for coming along today. I also see we've got Brian Thresh on the call. So Brian is the person who's showing off the heat pump in his garden and many of these photos in his net zero home in W12. So hi Brian, and thanks for coming along. But thank you everyone so much for coming along today, for all of your questions. We hope that this has been a really useful session. If you have got 1 minute, I would love you to just give us some feedback. So I've just launched a quick poll, which will just ask for your feedback. How would you rate this event on a scale of 1 to 5? If you can just let us know how you found it, that will help us understand if this was useful or not. And then also just how you found out about this event. Again, we're trying lots of different things in terms of marketing and getting the word out to different parts of our borough and our community. So really, really helpful for us to learn what works there as well. But other than that, thank you so much for coming along to the session today. As I said, we really hope it's been useful. Please feel free to reach out to me and provide any more detailed feedback. We would love to hear how we can make these more useful to you in future. And again, thank you so much to Tim and Roy for your presentations today.
And thank you to Emily for your fantastic sharing. Thank you, Emily.
Thanks a lot, everyone. Hope you have a lovely week and we will hope to see you again soon.
Thank you very much. Bye-bye.
Bye.
Thanks, everyone. Bye-bye.